This is the lesson for 4.1 in Algebra 1, and this is about slope. So let's go over a little bit of the vocabulary first of all. We're going to talk about, with slope, we're going to talk about rate of change. And rate of change is the measure of how two things relate, two different kinds of units of measure might relate. We think of it most commonly with time and distance, where we're going to compare things like miles per hour. That's a rate of change. Or we could have kilometers per second. We could also have other things that we could compare. Again, it's any two things related. It could be apples on a tree and how they change, how this change. But typically for a rate, we're really talking more about where it's in regards to with time. So we're going to compare distance to time. And so that's usually rate of change. But rate of change is just talking about thinking in data, the change in our y values being compared to the change in our x values, where the y's have one kind of unit of measure and the x has a different type of unit measure. When you think of change of y, that equates to, in a graph, the vertical change. So the change in y is this vertical change. The change in our x is a horizontal change. Another vocabulary word that we use when discussing slope is rise. Rise is the change in the y values, which we just talked about up here. That is the change in the y values. Again, vertical change. If we had 2 points, we would subtract our y values, and that would give us this rise. The run would be the change in our x values, or the horizontal change, and if we subtracted our x values, we would get that. So we're going to look at some coordinate points to talk about this. We're going to look at graphs to discuss rise and run. So again, this is more when we're discussing coordinate points, and this is more about a graph. The slope itself, so we've talked about rate of change, rise and run. What is that slope? Well, the slope is a type of rate of change. In a graph, we would think of it as the steepness of a line. So here's a line, and that line is going up. It's an increasing linear function, and therefore it's going to have a positive slope. Because it is facing upward, it's going to have a positive slope. Here's another line, and this is a decreasing linear function, and it's going to have a negative slope. So we're looking at the steepness of this line to talk about the slope, and it's going to have a positive slope, some positive number. This one's going to have some negative value. That's going to be the negative for that slope. When we have parallel lines, and this symbol right here, these symbols, this is like, you'll learn this more in geometry, that those have to do with the denoting parallel lines. Well, parallel lines happen to have the same slope. We can have many lines. All of these lines over here, all of these are parallel lines, and they all have the same slope. Special cases, there's two special cases to think about, and one is a horizontal line, one that is flat. And if you thought about it, if you're walking on it, it's a nice flat level ground. Well, a horizontal line has a slope of 0, and the reason it has a slope of 0 is it has no vertical change. It changes horizontally, but it does not change vertically. And so that vertical change would be y sub 2 minus y sub 1, which is 0, and that's where the slope being 0 comes from. If we look at this line here, well, this is a vertical line, and a vertical line is an undefined slope. And this concept of undefined, what does this mean? Well, undefined means, if you imagine that you were actually skiing down a slope, that's what, the steepness of a hill, you're skiing down a slope, and this is what your slope looked like, this straight up and down. Well, you're not going to be able to ski down that. See this person saying, oh no, because at the bottom of the hill, oh my gosh, they hit the ground. Look at this. You've got an arm, you've got a leg over here, another arm over here, and this person is undefined. Now, that's just to remind you that straight up and down, a vertical line, it's an undefined slope because you would become undefined if you skied down it. But the reality is, it's because it has no horizontal change. It does not change to the left or the right. It's just straight up and down vertical. And the x sub 2 minus x sub 1, this way we calculate the horizontal change, is 0. And you're going to see in a little bit that this is going to go in the denominator for an equation. And you can never have a 0 in a denominator, so we call that undefined. We use symbols. I want you to get used to some symbols. I'd like to always prepare you for this. And the symbol for change in mathematics happens to be this symbol, which is a Greek letter. It is not triangle. That is not what this means. It is the Greek letter and called delta. And that stands for change. So when we're going to talk about slope, we're going to say it's the change in my y being compared to the change in my x. So this is the way we could write the idea of slope. So if I give you 2 points on a line, so one of the points is point 1. I'm not giving you any numbers to start with. We're just going to start with some letters here. So some point, some unknown point, and it has the coordinate x sub 1, y sub 1. So I've got these 2 coordinates for this point. I have a second point. Well, again, I don't have any numbers here. I'm just saying point number 2 has x sub 2 and y sub 2. To find the slope, I'm going to subtract my y's, and so I have my y sub 2 minus y sub 1, and I'm dividing x sub 2 minus x sub 1. And that's going to give me my slope. So here's an example. I have 2 points, the point 3 comma 9 and the point negative 5 comma 1. And the slope is going to be my 9, my y minus 1. Oh, I'm sorry, I said that wrong. It's my 1 minus my 9. I read that wrong. My 1, my y sub 2, minus my y sub 1. So 1 minus 9. And then I'm going to have a negative 5 minus 3. So I have that there. Calculating that out, I get negative 8 over negative 8, which is just 1. So if I had these 2 points and I want to know the slope, it's 1. What does that mean graphically? So if I take those 2 points and I put them on a piece of graph paper, and I've got 3, 9, the point 3 comma 9, the point negative 5 comma 1, and I have a line that goes through those 2 points. I can start at any one of the points. It doesn't make any difference which one, but once I pick a point, I'm going to use my rise and run from that place. So I'm going to start here. I like to start here on the left. So I'm going to go up. And so this time I'm saying, I'm going up, and my rise is 8. My run would be how far it takes to go over. So my run is also 8. Slope is the rise. The y's are the rise over the run, which is 8 divided by 8, which is 1. And you might say, Miss Lobbs, when we did the numbers, we got negative 8 divided by negative 8. That's because we went in the other direction. We went back. And this other direction would be negative 8, and going down would be negative 8. So it all depends on your perspective, which point you start with. Let's do another example. And this is a fun one. The example is that Ms. Lobb's granddaughter, Fiona, was having fun, and she flooded the bathroom with water. And the question is, what was the rate of change? And we're talking about the rate of change in the water, how much water changed over time. And we're going to look at it by the data that's in the graph. So here's a graph, and it's important to recognize what I have on the y-axis, and it says gallons of water running. So this is in gallons. And on the x-axis down here, it says minutes Fiona is in the shower flooding the bathroom. So these are minutes, and this is gallons. We take the first piece of data that was calculated from looking at our water meter, and after 10 minutes in the shower, 25 gallons of water had been used. And 60 minutes later, unbeknownst to us, 100 gallons of water had been used. So connecting those 2 pieces of data, we can calculate what was the rate that water was flooding the bathroom. We find the rise, and we look at the data here. I went from this height was 25, and it's going all the way up to 100. So that means the rise was 75. And since we're on the rise, we're going this direction, it's gallons. It's following this axis, so it's gallons. The run would be from 10 minutes to 60 minutes, which is a grand total of 50 minutes. Reducing that fraction is 3/2 gallons per minute. Well, that's not an easy usable. It's perfectly fine in a math class, but we would change that to 1.5 gallons per minute. And that's the rate at which the water was flooding the bathroom. Here's some more examples. I have 2 points. We're going to find the slope. So we take the y's and we subtract them. We divide it by the x's that we subtract. We get 9 plus 7. Now, we're subtracting a negative. So this right here, it's going to become 9 minus 7 becomes 9 plus 7. And we get 16 over 8, which reduces to 2. So that's the slope going through those 2 points. And here's another example. 2 points. I subtract my y's. I subtract my x's. Once again, we have subtracting a negative down in the denominator. We get negative 10 over 15, and that reduces to negative 2/3. So that's the end of your lesson to watch as a video.